All right, today we're going to talk about calculating the slope of a line. So number one says pick any, and we're going to pick 2 points on a line. 2, we're going to draw a slope triangle. 3, use the slope triangle to find the blank change between the first and second points along the y-axis. So the y-axis runs up to down, that would be the vertical change. 4, use the slope triangle to find the blank change between the first and second points along the x-axis. The x-axis runs left to right, so that would be the horizontal change. 5, use the equation slope equals vertical change over horizontal change or we like to just call it rise over run. That's the easy way to say it. That's the shortcut, and that's a lot of ways that, or that's the way that most people will refer to it as. We're going to substitute the values from steps 3 and 4 here. Step 3, the vertical change, and step 4, the horizontal change, right into this fraction. So right in for the rise and right in for the run. Number 6, if the graph goes blank from left to right, so if it goes up from left to right, the slope ratio is positive. And if the line goes down, then I'm sure you can guess from left to right, the slope ratio is going to be negative. Okay, now let's take a look at the example. Here's the example, and we have some lines going in different directions. I'm going to start with line A, and the first step on this sheet was to choose any 2 points. Now, we're not just going to randomly choose 2 points, because if I choose this point here on this line, and I choose this point here on this line, I have no idea what the location of those 2 points is. So I cannot, on this coordinate grid, go 1, 2, well, it's about 3.5, and up about 1.5. I don't want any estimates. I want exact values. So I want to know where it crosses the coordinate grid, or where it crosses the lattice. So where it exactly crosses the lattice would be here. It would be also here. It would also be here, here, or here. There's going to be more than one location. And all you need to do is choose 2 of those locations. So I could use any 2 of those. And the reason I can use any 2 of those is because the ratio is going to reduce to the same form every time. Let's look at it. So choose 2 of these, form a slope triangle. So we're going to form a slope triangle between any 2. I'm going to use the furthest 2. Here's my slope triangle. Then find the vertical change. So you're counting blocks. 1, 2, 3, 4. That's the vertical change, or the rise over the run. 1, 2, 3, 4, 5, 6, 7, 8. 4/8. Well, that as a ratio can reduce. And we know that it reduces to 1/2. Had we chosen 2 points that were closer, like these 2, we would have had a vertical change of 1 and a horizontal change of 2. that's where I would have gotten the 1/2. However, if I would choose any of these dots, any two, I should still get the same ratio. So if I choose this dot and this dot, I get a vertical change of 2 and a horizontal change of 4. That gives me the ratio of 2/4, which still reduces to 1/2. Let's look at this line. From left to right, it is going in a up direction, therefore it is a positive slope. So we would say the slope of A equals 1/2. Now I'm going to erase all this. Let's look at line B. Line B is over here, and from left to right, line B is going down. So it is a negative slope. So when we write our slope, it has to have a negative sign in front of it. And again, we're going to choose 2 points. I like this point where it crosses the y-axis. That would be my y-intercept, and that would be 0, 1. And if we travel along this line, it also intersects here on the lattice grid at 1, -1. So they are pretty close. That makes an easy slope triangle with a vertical change of 2 and a horizontal change of 1. Vertical change of 2, horizontal change of 1. Rise over run gives me a slope of 2/1. Or we could just say it's a slope of 2, but it was a negative sloping line. So line B has a slope of -2. We said A had a slope of 1/2, and now we have to look at line C. Line C, from left to right, is also going down, so it's going to have a negative slope as well. Again, I like this point here where it crosses the y-axis, our y-intercept. And this one is not as steep, and the points are further apart. So I think it crosses right here. So when we make our slope triangle, our vertical change is 1, and our horizontal change is 1, 2, 3, 4, 5. Vertical change of 1, horizontal change of 5. Our slope is 1/5, and it's a -1/5 because it's going down. So let's talk about the slopes of these lines. One of them is a very steep line, and the other 2 aren't as steep. The closer we are to 1, the steeper the line. The higher the number or the value, the steeper the line. So it looks like B has the steepest slope because it is a whole number and it is above 1. And it looks like C is the least steepest line because it is the smallest fraction. And we only have one positive sloping line, and that is line A. You are going to work with slope a little bit more today. Go ahead and grab your resource page and get working.